Okay, I think we got a good quorum today. So the big SARA news is that we now have a gift shop. It's an on-demand store that has my daughter Cammie Russell designed, put the designs together based on input from especially the Eastern Conference Committee, led by Jay. Those guys sort of approved a bunch of the designs, and she put them together. So let me show you the shop. I put the address in the thing, but it's really pretty easy. It's saragifts.org. We also got the link set up in the front page of our website. So let me do a quick overview of that. You see how it looks. So you come up with our big dish here. Everybody see that?
Yep.
Everybody talk? Okay, good. So yeah, we got a big dish. Some featured products right now this is the spiral notebook for the conference. This is a sticker you can get. Here's the t-shirts or the sweatshirts. You even got a tote bag you can buy. Coffee mugs, of course. You got different shirts. This is what Helen. This is what I was talking about. I'm not even sure my wife would wear these, but I love radio astronomy. But uh, I'm trying to get my daughter to give some men's socks or something like that because I'm not sure how many will sell. Radio. I love radio astronomy thing. We also have the SARA logo on the back of that. Let's see what else. Couple radio astronomy shirts. Just one with our logo. The hats have got a lot of people buying the hats, key rings. I like this, the men's long sleeve pajama set. These are let me see if you get looking at that is actually the logo on there, the different colors and stuff. Mouse pads. These are another set of socks with the SARA logos on them, and more sweatshirts. And that's so far that's our offering now, but we are going to get more. And as soon as we get better ideas, we've already asked our Australian contingent to possibly send up some logos that they want put on there, and we can get some Australia. I think we might have. Let's see who here is not in United States. Detlef. Let's see who else. Robert Lucas. If you go on the site, it's possible I haven't set up the foreign sales part yet because they do something with taxes or they do something with shipping and stuff like that. So if you go on, send me an email if it doesn't process it, because somebody sent it one already and said that it wasn't set up for a certain country. I think I can set it up for certain countries. I don't know if it's we're in the startup phase of the stuff, but it works all United States. We've got 10 orders right now. People have ordered products, and but we don't have. I don't think any of those things are international sales yet. It will do international sales, but I think I have to do something else, and may have to get help from the to figure out how to set it up for that. Anyway, that's what we got. Um, we now have merch, and I think you guys are going to have fun getting it. Let's see. Let me show you. This is an example of the mug. It's a huge mug, 11-ounce mug, and she's got this on both sides. So yeah, this is good stuff. And let me know if the shirt, if you get something, if you don't like it for some reason, it's not quality. We haven't physically tested any of these, so I want to see if they don't look good for some reason, let me know, and we'll somehow change it out or change the logos or something to tune it up. Okay, that's all I've got. Let's see, Jay, got any Eastern Conference announcements?
Well, we're just about filled up on speaker slots. I'm right now working on the schedule with some updates from this morning. And I should be able to show that in about 5 minutes if you want me to screen share. But I'm needing to move a few things around to get them to fit right now.
Hey Jay, I had a question regarding that.
Sure.
I originally thought I was not able to attend, and I decided I'm just going to make it happen. But I can't really. I don't think I can swing the whole 4 days. So what I'm planning to do is try to be there Sunday and Monday, and then I'm gonna have to head back on Tuesday.
Okay.
Are speakers kind of spread out throughout all the days, or how does that work?
They are, and in fact, that's one of the things I'm working on right now. Is I'm trying to find a slot on Monday for your
Okay.
presentation, and it's
Well, yeah, I really appreciate that. I
yeah.
appreciate that. So,
Yeah, it looks like Dr. Montesi, who was scheduled for a 4:30 presentation, does not mind being switched later. So actually, what I'm typing right now is trying to get the schedule updated and putting you into the 4:30 slot on Monday.
okay,
I,
cool.
I, I appreciated your emails on that and explaining the need for the change.
Yeah, I was like, oh, I don't think I can swing it, and then I was like, I need to start doing things for myself, and I've had a lot of moving pieces, and I've been, taking care of adult children
Sure.
and stuff like that. And I'm like, I need to just make this happen for me, and I need to
Right.
figure it out. So
Well,
it's
that's
just
going to be good. Looking forward to seeing you there. And Rich, if I could have maybe another 5 minutes to finish typing on this, I would like to share it. And also on Friday, we got confirmation of our keynote speaker. So when I share the screen, I'll let everybody know who that is. And I think you're going to be pleased.
Okay, we'll go on to somebody else and let me know when you're ready.
Will do.
Okay, let's get Robert. He's our hardest time zone guy.
Good morning, everybody. I woke up about 10 minutes before the meeting starts, and I go, oh, no, I have to remember this. Anyway, for me, nothing new to report this month. Absolutely nothing new. Next month, it'll be much, much more to report. The radio telescope will be back online, and we'll make it a tracking mount. I should have that back. Should have it, designed and put together for the next meeting. Sorry about that. Thank you.
Oh, no problem. And work with your guys down there to see if they can get some kind of a Australian radio telescope logo we could put on some of the stuff.
Yeah,
That'd be fun.
I'll see what I can do.
Okay.
And as far as the international shipments go, I don't have to worry about it because I can have it sent to my California address.
Okay. Well, I think it works. So I may need to have one of you guys just try to buy something little and just to verify it works or not. But because I think it does international shipping. I just may not have it set up right.
I
Okay.
think the issue might be the Australian tax rules and everything. You may have to pay tax. I know when I buy stuff from Amazon, it has to be taxed. One time I tried to buy something from Amazon and tried to ship it to California, and they said, no, you can't do that. But luckily, I went to Disney and bought it there for half price, what Australia wanted.
Okay. Well, I think this thing will automatically add whatever national tax or whatever is required. That might be my setup thing that I haven't done yet.
I think the
Okay.
problem is you have to pay that tax to the Australian government somehow.
Yeah, I think this. We don't do it. The shop does it. So
They'll work it out.
Yeah, they'll work it out. All right. Thanks, Robert.
Take care.
All right, Edward.
Hello.
Edward. All right, there you go.
Can you hear me? Yeah. Okay. Yeah, we're here. Yeah. So for my side, there's really not much to report. Really, I've done some observations, but really not any new sources. So it's not very interesting to share at the moment. I've been working a little bit on my telescope mount project, but yeah, it is still kind of stranded, to be honest. So I'm currently thinking of like just leaving out the whole tracking part of the mount and just like setting it up as a stationary telescope, just doing drift scans. So yeah, the issue with that is that at 22 gigahertz, the beam width of even a 1 meter dish is like less than 1 degree, or it's around 1 degree, something like that. So your transits are only going to take about 1 or 2 minutes. So there's really not much integration time that I have for each transit. So that's going to be quite limiting in terms of sensitivity. But I hope they'll still be useful. So yeah, I think I'll just do some experiments this month with it, see if it's worth it, and then I'll report back in the next meeting. And that's about it.
Okay, great.
Hey, Edward,
Right,
I had a question for you. You mentioned, I think, a couple of meetings ago about one of your 3 meter dish that you were having issues with the shape kind of changing over time. Have you figured anything else on that? Like what's happening, or have you been able to investigate that some more? Just curious.
I haven't really looked into it much farther, but yeah, just looking at the segments of the parts of the dish, I think it's just like the surface. You can see it's kind of like uneven. So I think it's just like the mesh just got a little bit bent. That's just the issue, and I would have to redo the mesh to solve this. So yeah, that's gonna take quite a lot of time. And yeah, at the moment, like the 3 meter dish is not really my priority. I'm primarily using the 1 meter dish. So yeah, I guess I have to yeah, figure this out and really solve it at some point. But at the moment, it's not. I'm not really spending too much time on the 3 meter dish.
Okay. Any other questions? All right. Thanks. Ted.
I keep making little changes to ezRA and improving it or fixing it. It's about time I finally post them, so that's what I'm busy with lately. That's
Okay.
about it.
All right.
Hey, Ed, I was just talking to an old friend of mine, and it turns out he knows you. And I think he's actually active in your local group there. John Ensworth.
Very much so, yes.
Yeah. So we caught up the other day. It's been a long time since I've spoken to him, and so just another reason why I might need to make a road trip out there.
Well, we have fun things to show you. Sounds great. Neat.
Okay. Thanks. Detlef.
Yeah. Hello, it's Detlef speaking. Yes, I think I'm working on my receiver system for hydrogen. Normally I try to use 8 antennas and phase shifters. I think I have different RF problems, some cross-talking and some IP3 problems with the preamplifier and the phase shifter. But I think maybe in 4 weeks I could show better results, and I can show some results. Okay, thanks all.
Okay, thanks. Let's see, Preston.
I don't, excuse me, I don't have anything new this time.
Okay. Jay, you ready? All right, or maybe not. Don. You're on mute. There you go.
I'm actually here. I really don't have much of anything. Right now, let's see, look, maybe I can do this. There's my antenna simulator. You can see a couple of radio compasses that I modified. And that's to take the place of the dish. Oh, and there's the actual control system is right there in my hand. It's dual H bridge and a 30 ampere switching power supply that will drive both axes for the 16-foot dish. And this, what I showed you here with the radio compasses modified is to run the tests on the software and all that without using the actual dish and destroying it completely. So I can destroy this stuff, which is a lot cheaper, and before destroying the dish, which probably will happen too. Who knows? But the little controller is let's see, Robo Claw, and it's made by an outfit in California. They're pretty cost effective, about $100 to control 15 amps per channel. And it has Arduino, what do you call it, a library, Arduino library, and a library for use with things like Raspberry Pis and so on. It's the guy that builds them has been in biz a long time and knows his stuff. So I recommend that as a controller. It's all done. It's got place to put two encoder inputs are built in. There's motor current sensing built in. The detection of hard stops is built in and shuts off the motors. Motor temperature, not motor temperature, but the temperature of the controller is built in. I recommend it. It's quite a useful outfit, and there's also plugs into a USB to set up all the parameters, including PID control and that kind of thing. It's all built in, and there's a control. There's not a control language, but there's an interface to whatever you want to use, either Arduino or, which is C++, or what I want to say, what's the other one that's good lately? Well, whatever. So I'm working on that, and that's about where it is. Just about ready to get started destroying this setup here. What I did was to adapt the I took the radio compass part apart and use a very small two-axis motor, 12-volt motor, a little one. And on the other end of the motor, I put a sensor that gives me the same angle structure that I get off the big dish, so that has a complete setup on it for testing the controller. And it's the software that you have to test, obviously, so that you don't run yourself up against hard stuff and burn motors out and things like that. So it's all fun.
All right, any questions?
Yep, happy to do questions. Can't remember the answers very well these days, but then what the hell?
All right. Thanks.
You bet.
Helen.
Okay, I'm working. Can you hear me?
Yes.
Okay, I'm working on setting it up on my computer. I had problems with the computer. The hard drive has problems, and my camera is completely gone. They told me I had to get an external camera. So we are in the process of moving the whole show over to another computer so I can be up and running, hopefully sooner than later. I would have had it done by today, but I wound up having to work the last 2 weeks, so there wasn't a whole lot of extra time to get help. But we're getting there.
All right, great. Thanks.
I'm excited about it. Thank you.
Yeah. Jay, are you there? No, you're still working on that. Let's go with Jason.
I'm here.
Oh,
I can share when everybody is ready to look at it. It's not looking very pretty, but I think some of the high points will come through.
Go for it.
All right. As soon as I find my share screen. I've got everything but share screen here.
Should be on the bottom.
Yeah, but it's not.
Let's see. Let me try something here.
Sometimes I find it at the top.
Yeah, I just made you a co-host. That might give you some more power.
Okay.
You don't see it, huh?
Nope. Share screen is not here. I've got all kinds of things but that.
Oh, boy.
Please try Alt-S. Alt key and S.
Said I'm restricted from screen sharing.
Really? Oh, 1 second. Oh, something's coming up. Well, that's Ted's.
Well, let me just verbally run through what we have, if that's all right with everybody. The conference is going to have a tighter schedule this year than in previous years because we have many more speaker proposals that really, really sound good. And it's sort of difficult to say no to some of these presentations. So the conference will begin as usual on Sunday, August the 4th. Morning time will be time to arrive at Green Bank and for those attending in person and doing personal tours if you want to see the place. and we'll send out instructions to everybody on how you can set up tours through the visitor center. But it should be a rather interesting morning. We will open up conference registration around noontime in the Jansky lab, and the afternoon will be pretty much filled with presentations up through 3 p.m., 3:30, when Skip Curley will take everybody to the 40-foot telescope and give hands-on instruction and use of the telescope pretty much for the rest of the day. Dinner each day will be at the Green Bank cafeteria in the residence hall building. And then each evening we'll set up after dinner for outside experiments and demonstrations. And on Sunday evening, Steve Zekas will give instruction on the 20-meter Green Bank Skynet robotic telescope. And following all that, and maybe in conjunction with it, we'll have Drake's Lounge social for the rest of the evening. and that'll occur each evening as normal. On Monday, it will be a pretty full day of presentations, and I'm trying to mix this between online and in person. We have two special guest speakers that day. 11:15 in the morning, Ellie White, and many of you know Ellie, will be talking on her research into SETI. She was a fellow at, well, we all began to know her when she was in high school, when she started attending SARA meetings at Green Bank. She went on to receive a degree in astrophysics, was a fellow at Green Bank, and now she is doing SETI research and managing STEM programs for the state of West Virginia. So she'll speak with us right before lunch. Then after lunch is our keynote speaker, and he confirmed on Friday, thanks to Skip Curley for working this out, Dr. Jay Lockman will be our speaker. For those of you who may know the name but can't quite place him, he is the presenter on the Great Courses course on radio astronomy. He is one of the principal scientists at Green Bank, and according to his bio, he is their senior astronomer on staff. Should be a wonderful presentation. He's a great speaker. And Jason, you were asking earlier, we have you down for a 4 o'clock, 30-minute presentation on Monday. Tuesday will be pretty much an entire day of in-person and online sessions. We do have 2 slots that we don't have names for at this time. We have an invited presentation from Deep Space Exploration Society and from our Australian contingent. Those will be sort of toward the end of the day. And then on Wednesday, the one remaining presentation slot is at 10:15 on Wednesday. We have a 30-minute presentation slot available. So if anybody has something you really want to share, that's sort of the last opportunity. We will wrap up the conference, both in person and online, at about 11 o'clock, 11:15. And at 11:15, the Green Bank staff will take us on technical tours. And we're in hopes at least some of the telescopes will be involved. Right after the technical tours, we'll have our final lunch at the cafeteria, and many people choose to miss that so they can get aircraft, or their flights. So I'll have this pretty much wrapped up at the end of the day. I'll share it with Rich, and we'll find a way of getting this posted. It's still in draft form. The committee will meet next, in 2 weeks from now, the committee will meet and will finalize this. So sorry I don't have a graphic to show today, but it is really, really rough at this point due to some last minute changes. So any questions or suggestions, I'd be glad to take them.
Jay?
Yes.
This is Jerry Taylor calling. Say, I'm kind of the new kid on the block and have just gotten my feet wet with doing some very, very basic radio astronomy stuff. And I was considering about coming to the conference, but my technical background, I'm sure most of it's going to be well over my head, but I'm wondering if you have any thoughts on, as a newbie, would it be worth my while to attend? I mean, you mentioned that some people are going to have their equipment set up, and I'm just curious what your thoughts were.
Well, Jerry, really good questions. And I think most of us who got into this got into it from about the same place you are. Sunday is pretty much dedicated to beginners. No matter how experienced you are, you're still going to learn something on Sunday. But Ed Harfman is presenting sort of intro to radio astronomy. Starts with square one and kind of runs through the basics of what the different methods of exploration are, the meanings of basic terms, and then based on that, it's a good experience to go with Skip Curley down to the 40-foot and sort of apply some of the things, at least for hydrogen studies that you learn during the morning. And then we do have a couple of presentations that I think are really tailored toward entry level. One of those, it was just working on that a minute ago, is Jason's presentation. I think on Monday would really be of interest to people who are just trying to get their own small dish set up and dealing with some of the technical challenges of recording hydrogen. And then on right now it is scheduled for Tuesday morning. We're going to try to have a presentation on Ted Cline's ezRA program. And ezRA can support everything beginners through professionals, but the capabilities for helping somebody who's just trying to get started are rather considerable. So I would encourage you to come, and especially in the evenings, that's kind of fun because you get to go out back of the residence hall and see how people have set up some portable receiving and processing systems. And last year, for instance, who was it? I think it was Tom Hagen, perhaps, had built a receiving horn out of a can that he had bought at a local hardware store, and it worked beautifully. So I think it'd be a lot of fun.
Okay, thank you. I appreciate that.
Sure.
Can I say something? I think what you'll find, Jerry, unlike a few other organizations that I've been in a lifetime, you'll find that people in SARA will talk with you at all. I have found it to be a non-groupy kind of arrangement. People don't form into little groups and go off and ignore you. And you can talk to almost everybody in the bunch. It's from A to Z, including almost professional astronomers, in fact, one or two professional astronomers, and right down to total newbies, such as you purport to be. I doubt it somehow. But I would endorse it as a meeting to go to, both the East and the West. I've never been to an Eastern meeting. I've been to two or three Western meetings and have thoroughly enjoyed every one of them, including the ones at my old alma mater, New Mexico Tech. So by all means, if you can go, it's well worth it.
Okay.
And I think you will not be treated with disdain. Nobody will turn their back on you and engage their martini sucking friends. So I think you'll have a great time. I really do.
Okay, thanks, Don. Well, I can just kind of echo what you said. I know Alex in particular has been extremely helpful with me getting started. So got my 6-inch antenna going, and I got some pretty restrictive sight issues here, but I was still able to get a glimpse of hydrogen, even with that 6-inch antenna. So, all right. Well, thank you. I appreciate the advice.
The conference that is going to be in August, I'm registered. Does that include the Sunday so I could see? No, not televised. What's the term? Streamed the presentations on Sunday.
Yes, Sunday will be streamed.
Good. Okay.
Be, interactive on Zoom.
Okay. Thank you.
Okay, Jay, is that it?
Yes, that's everything I have.
All right, super work, and your committee is working fabulously. I like the way it's interacting.
Maybe one more thing to add. For those of you who will be making presentations, and I'm going to apologize in advance, we have to stick to a hard schedule because it's a hybrid conference of in-person and online. We just cannot allow presentations to run over schedule. So if you have a 30-minute block, that means 30 minutes for presentation and Q&A. What we found last year was the 3 or 4 people who tried to do their presentation in a TED Talk format were the very most successful. In other words, keep your talk to about 17 to 20 minutes and then open up for about 10 minutes of Q&A. What that lets you do is use 10 to 12 PowerPoints or slides to give the high point of your paper. And then your paper or your full report can run as long and as detailed as you want it to. So what you do in that 12 to 50 or 12 slides, let's say, or 20 minutes, is you're really doing a sales pitch to get people to read your paper. And the feedback we got from that was absolutely impressive. People like that. Especially those of us who are getting a little older, our span of attention gets less. And it really does seem to work well to have shorter presentations, detail in the paper, and then just use your platform time to give the high points. So what we will do is give you a 2 or 3 minute warning at the end of your presentation block, but literally the mic has to be cut off at the end of the time so that we're respectful of the online participants. But we'll talk that over more with participants or presenters as time goes on. But just so you know, and as you're planning your own presentations, it's better to try to keep it a little short than to push the time.
All right. Thanks, Jay. And Jerry, since we just had you on, Why don't you tell us a little bit about your setup you've got so far that you were able to detect hydrogen with? And I want to emphasize, when I went to the Eastern Conference for the first time and the Western Conference, you see these giant radio telescopes, you go see the computer rooms, you go see how they manufacture the feeds in the professional side. And then you get to go, Skip will show you how to actually get hydrogen on a big dish. And then Steve Zekas will show you how the robotic dish works, which you can do from your house. And you just walk away so motivated that this is just like, this is your hobby for the rest of your life. So I think that that's really good. But anyway, enough with me. Jerry, what's I don't know if you can show your horn or anything like that, or your system you got set up. Did I lose you, Jerry?
Can you hear me now?
There you go.
Yeah. Okay. All right. Sorry, I had my mic turned off. Yeah, with Alex Pettit's help, he sent me some plans. I basically just took the 6-inch cake pan, rolled up some aluminum flashing, put it inside and adjusted the height, and put the probe in there. And I was able to detect hydrogen with it, which was surprising because I've got I probably got the world's worst location for doing radio astronomy. I live in an urban area. My house is, I got houses on either side, 25 feet away, pretty much an entire tree canopy around me, but I got one small window out to the west. And if when I fire up Stellarium, I look for that arm of the hydrogen coming through. And I put the 6-inch can out my window, I can actually detect hydrogen. And so I'm at this point, it's been pretty frustrating because, to do things right, I'd have to pack up all my gear and go to another location to do decent work. But right now I'm fighting with RFI, and which I'm sure everybody does. So I'm hoping maybe I could pick up a few pointers that will help abate some of the noise issues I have. By the way, I also did purchase a Apache Aggie from Alex, and I've been using that. And that antenna works too good. It picks up noise great. So if anybody has any tips on getting rid of RFI, that would be great. So that's pretty much it for now.
Yeah, I think an EMP pulse is the only thing that'll work. So, okay, we don't sell those at the store.
Okay.
Okay, thanks, Jerry.
All right.
Glad you have you on. Jason, what do you got?
All right, so I'm gonna share my screen here, and what I'm gonna do is pull up my my presentation that I put together for the conference, and I'm just gonna skip through the preliminary stuff and go to the end result here. So I've done. Can everybody see my screen?
Yep.
Yep.
Okay, cool. So I've done a 10-inch extension of the radius of my dish, so you can kind of see around the outer edge. The original one was where the cover kind of stops, and then there's another patch of cover after that. So I extended that. If you remember before, my well, here's the previous one had this window screening shield to keep ground noise out. So I just extended it, and it really it works well. So with that new setup, my focal ratio is 0.31, which actually improves the ground noise quite a bit. And I did verify that the cake pan loop feed was working wonderfully. So I've switched to using that exclusively because it's so straightforward to mount and dismount from the dish. I've also kind of updated my observation planning. So once I got M31 and M33 and M101, I started looking at some more recent surveys, hydrogen surveys of nearby galaxies, and I found a whole host that were, I believed, based on the results of my first three, that they were possibly in reach. And so I using the 2008 survey published called I think it was the H1 Near Galaxy Survey, I think is what it was called. I basically just ordered the galaxies by their maximum flux, peak flux, to try to put the easiest to the hardest. And anything that was smaller than, much less than 3 Janskis, I figured was out of reach. But there were several that were within the order of magnitude of what I'd already detected. So anyway, I've begun using the Stellarium app on my phone to plan my to figure out my transit times for these objects. And now that I've actually done a really good sun scan measurement of the half power beam width of my dish, I've been able to I can set my field of view on the Stellarium app to 7 degrees, and then I can adjust the clock setting and see where the object enters and exits the field of view, and then I can set my observation plan based on that. So then I try to capture a pre-transit and post-transit scan like I did before. So I try to set my center frequency to center the object, most of the time to center the whole object nicely within the flat portion of the receiver band. So then I do my drift scanning and post-processing and data analysis. I'm using the Hawk RAO VLSR calculator to adjust my velocities for the VLSR correction. And then I'm doing my pre and post transit scans as my reference, again, like I did before, and converting to dB. And then I'm flattening. Before I was using a linear function to flatten my data, but what I found is sometimes it's not flat, sometimes it's more of a curved response. And so I started using up to a fifth order polynomial fit to flatten my data. And I just kind of do it by, I'll have Excel generate me a fit line, and then I'll use that as my starting point, and then I'll adjust it manually until I get it where I want. Here's an example. So M33, I ended up using a second order, or a quadratic fit line. It's almost flat, but it's a very shallow parabola, and that worked well. And then for NGC 2403, I used also used a second order flattening function. And then for M101, I found that I needed to use a fifth order polynomial fit, but that actually did work well. And as you can see, the orange is the flattened data, the blue is the original, and it flattened it right out. So I'm kind of refining my analysis technique to overcome some of the limitations of the stability problems of my receiver setup. So these are the galaxies I've detected so far. So M31 you've seen before, but I have refined my analysis of the original data using the polynomial fits, and it actually flattened it out much better. And I've got a much more, I was able to use much more of the bandwidth of the data to see it more of the profile. M33, again, that's been seen before. M101, And then I've added 2 additional ones. I've added M81. And M81, I am going to try to get the entire profile. Right now, I've just gotten the left side, mostly around the redshifted peak, because this one, as you can see, its proper velocity is almost 0. It's just barely blue shifted, and so it kind of straddles the local signal, and so you can see that crazy signal in the center. That's what was not the portion of the local hydrogen signal that wasn't completely removed by my reference method. It is knocked down quite a bit, but it's prominent. But what I'm hoping is that I can get a good transit scan of it where the center frequency is centered more at 0, and hopefully I can get both sides, and then you'll still have that crazy local signal in the center, but it'll only take up a small portion. So more to come on that. And then finally, I was blown away by the NGC 2403. I couldn't believe how well that came out, because we're starting to get down to very small signals. And I think, I've tried getting IC10, and I've also tried getting M74, and I've been unsuccessful. I've done about two or three attempts on both of those, and I'm beginning to suspect that some of it is just luck, and I think there are probably external conditions, noise wise, and maybe even thermal noise wise, depending on the time of day and where the sun is, that are causing interference that's decreasing my sensitivity sometimes. So it is, I'm getting better than a 50%, success rate on these things, but it definitely isn't 100%. And sometimes it's like rolling dice. So, but persistence pays off, right? So anyway, that's what I got for today. Anybody have any questions?
Can I ask a question?
Sure. Yeah.
Sorry. Yeah. So Andrew here from the UK. Yeah, but thanks for that. This is probably a very silly question. So if so, please just realize I don't know a great deal about these things. So the last meeting, we had some discussion about you've obviously got fantastic results, and the last meeting we had some discussion about how good the parabola had to be on a dish in order to be able to pick up a good signal. And there were suggestions that it needed to be incredibly accurate. We were talking about 10th wave, and then I was told that it needed to be like 20th wave variation, and if it was worse than that, that would be picked up on a dish. But your dish, if you don't mind me saying, does not look like it's got a 20th wave accuracy on it, and yet you're picking up these incredible results with it.
Yeah, there's that academic theoretical idea that and there's actually published simulations. In fact, I even used that early on in the design to try to figure out, okay, how good do I need to be? And what you find is, in fact, I'm going to share my screen because I think I have that somewhere. I can't find it right now. But there was a paper that did theoretical analysis on, and they showed a plot of dish efficiency as a function of RMS surface area as a function of wavelength, right? Or as a ratio of wavelength. And what you find is it gets really poor if you're worse than about 1/15. If you're at 1/10, you're still above 50% efficient. So you're still working. You're just not working as well as you could. And below 1/10 of a wavelength, it starts dropping off very quickly. But once you get above a 20th, it really starts approaching, between 75 and 90% efficient. So you're starting to get diminishing returns at that point. So, but the other thing to keep in mind is we're talking RMS surface area or surface error. We're not talking peak. And if you think of the wavelength is 21 centimeters, so, a 20th is like 1 centimeter. So that's not tiny. And if you think about the way, if you think of just like a one-dimensional signal processing case where you have a waveform, that's got peak levels at, a certain value, the RMS value of that could be, half or, 0.7, depending on, what. And so you really can have more, you could have more variation peak wise, and still the overall shape could be close enough. Does that make sense?
Yes,
So,
it does.
And what I found
well
is
explained. Yeah, thank you very much.
Yeah, and what I found is experimentally, smoother is better, but sometimes you just have to try it and see if it works. And it's like nothing's lost from just trying it, And I kind of wanted to see, how well it would work. Now I know that my efficiency is not great because I'm still only getting, with the Milky Way peaks, I'm still only getting between 1 and 2 dB above noise. And with a dish as large as mine, I mean, a lot of people with 2.5 meter dishes are getting 3 or 4 dB above noise, with theirs. So it's definitely performing more poorly than really smooth dishes. But for doing this things that I'm trying to do, where I'm trying to get these, I'm doing these long transits and trying to gather, I'm doing drift scanning and I'm trying to gather lots and lots of data, really to get these very small signals. What matters more is aperture rather than just plain signal level. And because as my aperture gets larger, I'm able to reduce, I'm able to get enough signal to noise ratio on these really weak sources to actually see something. And as my goal is to just detect, right, and see how much I can detect. Now, obviously, if I'm wanting to do a more detailed survey, I need a better setup. But the kind of the fun of this is what can I do with this really simple basic setup that doesn't have any bells or whistles and that kind of thing. So,
well, thank you very much.
Yeah,
Dave's got a question, I think.
Yeah, I think I missed it. How large is that dish?
It's actually exactly 3 meters now. So
nice.
It started out at two and 3/4, or like 2.74, and then when I added the extra extension, that brought it to exactly 3 meters. And,
I can't tell you how excited I am about what you're doing, because I've been an optical astronomer, hobby astronomer for 50 years. I had no idea we could detect, as hobbyists, kind of, other galaxies' hydrogen emissions. That's pretty awesome.
Well, up until a few months ago, I didn't know if it was possible either. It was kind of funny
it's
when
like a whole new world opening up.
I've been trying to detect M31 for like 2 years, and when I finally got it, and then immediately after I got M33, then I was like, okay, how much further can I push this? Like, when am I going to reach the end of what I can do? And I have not reached the end yet. I'm still actually pushing it. So
I know what I'll be pointing at tonight.
Jason, tell us what you have for electronics change. what amplifier stuff like
Yeah. So actually, I'm going to share my screen again because it's actually on my presentation. I'm going to back up here. Let's see. Got my setup. So I'm using a Noelec H1 Plus Sawbird. Now the one that I have shown in this photo is the bare bones. I'm actually using the regular one with the case. I just didn't have a photo of that one at the time. Although they both perform, in my setup, they both perform about the same. I can't tell a difference really. So this is my feed. And then my receiver is literally just Nolec Smart T SDR, and I've got it mounted on a heat sink. Not because it's getting too warm, but I found that a lot of the stability of my receiver response was because of temperature drift in the SDR itself, and so mounting it to a large heat sink stabilized the temperature a lot. Another thing that's helped is I've recently purchased a 25-foot cable, and so I now can have my dish outside and run the cable through my window and have my laptop and my SDR inside the house in a climate controlled environment, which is a lot better too. So yeah, that's really all it is. I mean, I've got the feed, the Noelec Sawbird filter LNA, and then I've got the Smart T SDR, and that's it. I mean, that's all. And then I've got a laptop. I got an aging Toshiba laptop. It's probably like I bought it in 2015, so so it's probably gonna die on me eventually.
Since you already have the bare bones version of that LNA amplifier, it would be fun to play with the internal resistor for reference samples. Cool. This is great.
Yeah, which I have done that in the past. With my when I was doing Milky Way scanning, I did I think actually that one had a manual switch just soldered to the header pins to allow me to switch it. But yeah, remotely controlling that would be cool. And it would also allow me to, I think, get a flatter response.
Well, my point was that ezRA can take a sample from the sky, take a sample from the resistor, take a sample from the sky.
Yeah.
And therefore, you're up to date. I know you're trying to take pictures before and after and clean up your signal. Maybe ezRA can help there too. Great.
Yeah, and the only limitation I'm having right now with ezRA is the sample rate is slower, and so I'm getting less samples per unit time than I do with so that's the only issue at this point. Which I am using ezRA's collector for when I do sun scans. I use that a lot, and then also if I'm doing scans of the Milky Way. Although right now I'm just using the off frequency calibration rather than the actual internal resistor switching. I haven't delved into that yet, but that will be something I'll be delving into in the future, though.
I also use the MIT Haystack software, which I've modified for those reference samples too. So that's an option.
Okay. So is that one, is the MIT Haystack software, is it more of an executable that's more mean and lean, or is it also
it's written in C, and so I'm thinking it may be actually taking more readings per sample.
Okay.
On ezRA, you can certainly have more samples by reducing the number of readings that you integrate.
But
you're going through a whole lot of layers so that it can be more transparent and educational with Python. And then there are also other collectors, but they don't do the reference samples. So at least I've modified the Haystack. So that's a possibility.
Yeah, I might get in touch with you offline about that because I might be interested in looking at that as another experiment to do. So
The only trick is that Haystack currently runs. Well, I don't know. It runs at least on Linux. Is there a way to make Windows work too? Question mark.
yeah, or that might be a motivation for me to delve into messing around with Linux a little bit. So yeah, good things, good thoughts.
Now
I
I've
have,
got.
I have a
Oh, go
question
ahead.
about that too. Since you're doing drift scans, I guess, right? Can't you just
Mhm.
use some of the area before the galaxy or after the galaxy as your
Yeah, that's
reference?
what I'm actually doing. But the problem is that in a lot of cases that it's still a very long period of time. So I'm having for instance, the ones that are very far north, like I can't remember which one, M81, I believe. Uh, well, and the NGC 2304, both of those are far enough north. They're close to the pole, not close to the pole, but they're at quite a high declination, and so their movement across the field of view is very a lot slower, which means I get more time on transit, but it also means that there's a lot more time for the receiver system to drift around as far as its response curve. And so what I find is that what I find is that the pre and post scan reference method works well, but I'm still dealing with receiver stability issues. And there's times when I'll get my end result is so curved and convoluted that I can't really flatten it. And so in those cases, I have to throw the data out and try again, So, and I haven't really been able to find a good uh, a, a good way to I haven't been able to identify what the main source of that is, or if it's something I can control, because I don't know. I've done everything that I could think of so far. I've pretty much stabilized the temperature on the SDR, which was a big factor, and that did improve it a lot. But I think there's also probably some issues with thermal noise background just from temperature variations in the environment, not due to the response of the SDR, but just due to the environment itself. Because granted, my portable dish does have a lot of structural members and things that are in the optical view of the feed that I can't get rid of because of the design of the dish. And I'm sure that during certain conditions, those are generating more noise in my system than at other times, probably due to thermal noise. So, but yeah, it's always system stability is the biggest challenge at this point because of the length of time that I'm integrating. So,
Okay, and Edward's got a question.
oh yeah.
Yeah. So yeah, once again, amazing work, outstanding, and I have a couple of thoughts and questions about this. So first of all, I think you mentioned at some point, but can you please remind me, like, what is the material that you made the dish surface of?
It's Faraday fabric. So it's this fabric that you can purchase. I purchased on Amazon. I think it was about $70 for a roll of like 260 feet of it or something. It was a lot. And let's see. Yeah, and it's funny too. We were having a discussion about this on one of the social media groups, and they were talking about how the stuff is really great, but somebody was was reluctant to purchase it when they were looking out online, because it seems like the market for it is driven by people who have funny ideas about 5G. These people who think that cell phone signals are killing us or something like that. So it's kind of interesting. It's like the market's being driven by somewhat dubious sources, but yet the material is very good, and it's very it performs well. One thing that I was really surprised is how light and thin the stuff is and how strong it is, because it's basically like tent material. And when I got my first shipment, I was like, I was surprised at how small the package was and how light the package was, because I ordered a lot of it. It was quite a length, and yet it fit in this small box, and I was like, but yeah, so the stuff is it's really good. And Alex Pettit was the one that turned me on to it. He had tried it out on some of his I think he was making dishes out of photo flash umbrellas, and so he was the one that kind of blazed the trail on using that stuff, and it definitely works. And then I just attached it to the plywood structural members using upholstery staples. So it's very low tech,
Okay, that's
the only thing
cool.
the only thing I didn't buy from the local hardware store was the material itself. Everything else.
That's pretty cool, actually, because I'm using this very fine aluminum mesh that you would like to put like in your window, for example, but it has a tendency to like deform over time. So I think that's an issue with my dish. So I might consider actually replacing it with this Faraday stuff.
I can post a link to where the product that I got. So for anybody who's interested, I'll do that while I'll try to post it in the chat here in a little bit. So.
Okay. And the other thing I wanted to ask you is like when I was looking at this list that you presented of the integrated flux densities of these galaxies, it really struck me that like the other galaxies besides M31 and M33 were like about an order of magnitude weaker. So I'm wondering like how much more difficult like were these galaxies to detect compared to M31, M33?
Yeah, that was really surprising to me, because I saw the same thing. I was like, wow, I don't know how much farther I can go, but I was like, there's no harm in trying, And what I found, let me see if I can. I'm going to go back to that list for a minute, because let's see here, because yeah, so M31 is a little over 100 Janskis. M33 is about half, and then M101 is like what? It's more than it's an order of magnitude smaller, but then several others are within that same range. And so once I detected M101, I realized that the others were in reach. And yeah, it is. M101 is definitely a smaller. It's not as nice of a profile, because the signal's quite a bit smaller. But as you can see in the results, I mean, it's clearly there. Now, I mean, it took me, I had to spend the equivalent of 2 or 3 hours of integration time on it to really get that to show up well. But I was surprised. I mean, I thought it was rolling dice to even see it at all, and I was surprised when it did show up. And that was like, okay, now we've detected the top tier one in this next order of magnitude down, and there's about 5 or 6 more that are within 20% of that. So I was like, okay, now I can go forward, and I've got several more within reach. So, but I'm starting to see that it's a little more intermittent at that level. I'm successful maybe 40% of the time rather than 100% of the time. So.
Okay,
Persistence
thank you.
pays off, though.
Okay, and let's see. And Dave might be able to answer this question, but the two peaks between the that show the blue and the red shift that shows you where the spiral change. I mean, which side of the thing you're on. The difference, the distance between those two in time, can we actually tell the orientation of the galaxy to our line of sight? And so we can actually maybe figure that out and maybe confirm it with a visual.
So, what you're seeing in the profiles I'm gathering, you're seeing an integrated spectrum of what's virtually a point source at that point. So you don't get any spatial orientation information. It's purely velocity. Now, J.J. Manto's original paper, he was only able to do this for M31, but M31, as everybody knows, or as most of you I think know, is a very extended source. It's at least three degrees on its long axis in the sky, right? So he was able, with his 3.3 meter dish, which I believe had a half power beam width of about 4.4 degrees, he was able to actually do a grid survey spatially on it and get and compare and actually create a more of a spatial picture of where the centers of the two peaks were. And so that's how he was able to actually get a spatial survey. So in order to do that for these smaller ones, you would need a large enough dish to where your beam width was small enough that you could get enough resolution to actually map it in a grid, right, spatially.
I think you don't need that to figure out the orientation, because if you got a visual and you can compare that with the
okay, I see what you're saying. Okay, so what you're saying is how oblique, or is it face on, or is it edge on, or
right.
Okay,
you can almost tell the angle
that is true. That you're right. And actually you can see that in some of my profiles. For instance, Andromeda is very edge on, and so that's why I can't even fit the entire spectrum in one take. Even if I didn't have trouble with the redshifted being buried in the local signal, I can't fit it all in the bandwidth of my receiver because it's so wide, because it's so edge on. M33 is tilted, but it's more like 45, and so it's narrower, or actually it's probably even more face on than that, and so it takes up narrower bandwidth. And then if you look at M101, it's very, very narrow because it's almost face on. And in fact, a couple of the ones that I haven't detected yet are so face on that there's only one peak, because they're not separated. So you're exactly right. Yeah, that definitely could be done.
One of my goals for this organization is not just to detect, but to analyze and see if we can find astronomical physics data from this.
Yeah.
And that's one of the things we're seeing there, is that you can actually see where the angle is based on that detection. You just maybe haven't done it yet. You're so happy to get it detected that now you have to analyze and see if that can work. And I'm thinking,
you can see with just an inspection, you can see qualitatively this one's more edge on, this one's more flat. But yeah, doing actual computational quantitative analysis of that would be more involved. But it's definitely, the data's there. I mean,
right.
You know where the peaks are, they're in the right place. So
all right.
Yeah,
well, that
so
might
definitely
be any of the mathematically inclined want to go and actually see if they can map that based on your data, and then show us how to do it. That'd be wonderful. Okay. All right. Well, thank you, Jason. Great work. And let's see, did I lose who did I lose? 1 second here. Oh, Andrew.
Hello.
Hey.
Oh, I don't have a great deal to say today. I think I mentioned last time my mum had died, sadly. So, I mean, spending much of my time sorting her funeral out. I'm also trying to get a spectrohelioscope to work. But what I did mention, I think, which if I mentioned last time, might not have done, in my attempt to try and improve the resolution, or at least improve the signal to noise ratio more accurately, on my hydrogen mapping exercise, it had all stopped working. So Ted did one of his usual help out mentoring sessions with me, and we worked out that there was a connection that had come loose, and that's been sorted, and voila, it's now getting signal again. So I'm starting my process again of trying to get a better signal to noise ratio. What I'm trying to do is my original mapping, which collected signal with drift scans for 48 hours, showed the close arm of the Milky Way very well, and then has shown up the one behind it quite faintly, and using a few techniques in Photoshop reminiscent of astrophotography processing, I've managed to sort of pull out a bit more of that data from there, make it look a bit better. But I'm actually now hoping to be able to improve that even further, so that those further arms become more visible with possibly a little bit more detail.
All with a very small dish.
Yeah, 86 centimeters. Yeah. So, but it's doing very well. I'd also like to try and get my Radio Jove setup going again. That's been stuck in a box for years.
Okay, great.
You say 86 centimeters?
Yeah, it's I know it's a weird size. It's actually an ex-military dipole array, something called for the Farming Trifid system that was used here in the UK. So it's actually a square, 86 centimeters by 86 centimeters with 16 dipoles on it, or what's called Band 3 in Europe, Band 3 military communication, which covers the hydrogen range. And I know that there have been some debates about how good it is. It seems to be doing the job quite well, but its main feature is it's as robust as anything as you might expect a piece of ex-military kit to be. It lasts, which is more than could be said for the new grid antennae that they sell, which are okay, but rather, as I found out when one fell over on its stand, don't really cope with that very well at all.
So, have you done a sun scan with it to try to measure the beam width to see what its half power beam width is, or?
No, I haven't. But I think Ted and I were looking at the data that was coming out on ezRA, and I think we calculated it about 15 degrees or so.
Okay, yeah, that sounds about reasonable for that size, probably. So, yeah.
It seems to, I mean, comparing what other people have put in the journal and on this group, it seems to perform at about the same level as an 80 to 100 centimeter dish would, as you'd expect. But maybe what I need to do now is get some of that material you've mentioned and build it up around the side and put it up in a great big parabolic dish. Although I think my wife would go mad.
Okay, great. Thanks, Andrew.
Pleasure.
Dave, are you there?
I am.
Well, I don't know if you got any radio astronomy setups, but what do you got for optical?
I run a 12-inch LX200R and a home-built 10.5-inch f5.6. That's been my passion since I was 14. So, may I share my screen? I have a first light report. Sure, I'll keep it brief. I'm sure you guys have seen this a million times, but it was exciting for me. So this is my little setup. I have a 1 meter new elect, I think is who sells this. It's based on 1420, the feed, and a new elect H1 LNA and filter, and then an RTL SDR. And so I used Stellarium here to kind of show a visual view. And this is pointed due south at 20 degrees elevation. Locally, I'm in Maine, so about right here. And this is my little couple dB, maybe half a dB of signal using the IF average tool in SDR Sharp. And I calculated this to be about 31 kilometers per second in relative velocity to me. So actually that's absolute velocity. Sorry. Yeah, that's actually this band of the Milky Way. I have a couple of really short I also figured out how to make the multiple files capture work on the IF average tool. I don't know if everybody's figured that out. It wasn't straightforward. So I think that my the combination of Stellarium and my IF average window pretty much confirms that that is H1 in one of the arms, centered about right here. And this was, I don't remember the times now. It's a busy time of year. I'm a farmer also, so spring is this. That was during the day. And then there's a night, a different arm of the Milky Way, and you can see that it's blue shifted on the positive side rather than red shifted like the other arm. So I don't know. I guess it works. I have it all rigged up on my front porch, and so I was pretty excited about that. Also really excited about Jason's work with the other galaxies. I'm really anxious to start looking into that too. I don't know, pretty clean signal. So
Dave?
Yes.
Yeah, go. Can you tell me again what are you using for a dish? Did you say you're using the Newelec wire
a 1
grid?
meter? Yeah, I think it's made by Newelect or sold by Newelect. It's a 1 meter. It looks like the Wi-Fi parabolic reflector, kind of oblong and not quite a meter tall, but a meter wide.
Yeah.
I think it was like $80 or something like that. I can't remember.
That compared to what I've been using the K antenna, that bump was enormous. I did
really,
yeah. With my K antenna, I got 0.14 dB above background.
0.14, okay.
Yeah, not much, but so that bump you got looks enormous to me.
Yeah, I'm glad everything worked, and so I do have a working system now, and now it's just time to refine it, make it better. I am still working on the azimuth and elevation gimbal to drive the telescope. Right now, it's mounted on a T-post and a variable elevation mount kind of thing, fixed mount. So, yeah. Anyway, that was it.
Hey Jerry, I was just thinking, you were talking about the K-antenna. Another option, if you for building something really straightforward and simple. My first system was a corner cube reflector that I built out of, square dowels, I guess you call them. And I just covered it with window screening, and it had little 3/4 wave. Anyway, I'll send a link. I'll post a link of I've got a YouTube video on my channel where I actually document that and show how and it performs really well, and it's really easy to build and
Okay.
relatively inexpensive. So
Yeah, I appreciate that.
All right. Let's see, Dave.
Sorry, apologies, Rich. Apologies. So
ahead.
just very quickly say to Dave, that's the new elect dish that I tried as well, and it performs almost identically to the Farmagun array that I've got with similar circumstances. But just my advice to him is strongly don't let it fall over.
Yes, it's not. It seems like it's pretty fragile. I'm guessing the beam width probably is in the order of 10 degrees or so. I'd have to look it up, but yeah, it's not a very tight beam width. That it was just sort of a proof of concept that I could do this. Back when I first started looking into it, I just wanted to build something that worked, and now I can swap out the antenna or the LNA or the whatever, software. So yeah, it's good for now.
Let's say the antenna works fine. You do a nice mapping exercise with it, and you'll be able to demonstrate dark matter with it without any problems at all. As a farmer, you have far better signal to noise ratio than me, so you should do better than me. I'm in the middle of a town.
Not very much RFI here in the middle of the woods, so I'm lucky that way.
Roads here, so but yeah, you'll be fine. It'll work very well, but it's just as I say, just make sure whatever your tripod is firmly attached to the ground.
Thanks.
It doesn't get blown over in the wind.
Mm-hmm.
Well, thanks, Dave, and realize that that's an excellent picture to put as an observation report for the journal. Is just take that snapshot of you getting that, and then put a little paragraph about your setup, and 2 pages, and that's a perfect observation report. I'd love to get that for this next journal if you can do it.
I'd be happy to. Maybe you could email me a link or something to the instructions on how to submit. I've never done it before.
Oh, just send it to me. Just put a 2-page, on Word, and
okay,
copy that 1 picture, and then just email it to me.
Okay, a little parts list and a little description. Yeah.
Yeah, just here's how I set it up, and here's my results, and you got a total of 2 pages with the picture in there, and I'll put that in the journal, and you're now a published author. And
so SARA has their own SDR software. Am I correct?
Well, we'd used the SDR Sharp originally with the microwave dish, and that's the scope in the box setup. Ted came and upgraded that whole system, and my recommendation is you load Ted software, and with the system you've got now, you ought to get beautiful results. It does all of the analysis for you. It does all the pictures. It does everything you ever wanted, and you could probably do the whole galaxy, everything with Ted software with your system without changing anything, except the software.
I see the link or the note Ted posted. Thank you.
Yeah. And I'd contact Ted to help him set up. But I think you've seen a couple of the other people with very minimal systems get fabulous results, and just the pictures coming out with their small dishes from the analysis of his software, that's wonderful stuff.
Mm-hmm. Yeah, so I'm afraid I think I'm getting aperture fever now, though. So
yeah,
Jason.
Well, we've got a 60-foot dish. We got a 60-foot dish in Haswell for the Deep Space Exploration Society. If you really get aperture fever, and then you too, Jason, I'd love to see your software on there. Arrange a trip. That's the dish, and oh
wow,
it's a 60-foot dish, and we're set up to hook up anything. A new elec. I did pulsars with this thing when we set it up. We got our first pulsars on this. But the stuff that you guys are doing with hydrogen, we have not done. We've not done anything with hydrogen. I mean, I did the initial hydrogen stuff, but we've not done the analysis with hydrogen. And by the way, it's got a 0.8 degree beam width.
Wow.
So I could point at anything, but I think that that'd be perfect for Jason's to attack galaxies with, because we can point and track anything.
Yeah, I was thinking the next thing I would want to do with something like that is go after the Leo cluster. That would be really cool.
Well, I'd love to. You tell me when you can come down. It's Haswell, Colorado, and we'll work out a trip. And the thing's set up to go anytime, and just need to get somebody down there with you to run the system. You plug in yours right to the feed, and you're off and running. Go ahead, Don.
I just say I'll second that. It's a good idea.
Don's on the board for the DSCS, and yep. Yeah, I think with stuff you guys are doing now with the little stuff, just the analysis and the hydrogen, we just have not had time to go do that with the big dish. Though you could plug your system, bring your system, and just plug it in with your software, and now you've got a 60-foot dish instead of a 1 meter dish. All right? So we'll invite any of you guys to come down with your system sometime. And by the way,
of course, it has tracking, which would help here too.
Oh yeah, absolutely.
Well, and with you said a 0.6 degree beam width, you could start
0.8 at
some of those you could actually
0.8 at 1420. Yeah.
Yeah, 0.8. Okay. That's small enough that for some of the larger ones you could actually do a spatial grid and not just a single.
You can do a proper raster.
We have a raster scan mode. So we can sit there and say, point at this point, and then raster around it and collect data.
But of course, they want to get the spectrum. Does it record the spectrum? Do you know, Rich, or or just magnitude at this point? I think, or I suppose, does it collect the data, the spectrums through all that data collecting?
Well, we don't. It doesn't matter because we're getting it right down from the feed to an RF channel. You bring your equipment in, plug it in. So if you got a spectrum system to plug in, you just plug into our feed.
Yeah,
we do the tracking for you.
ezRA is just at the point where you could collect all that stuff together, location and spectrum. So okay, yeah.
Okay. Let's see. Did we get everybody? I think we got everybody. Bob, do you have anything else? I don't think I let you talk.
No, I'm doing okay. I really enjoyed lots of good conversation. Appreciate all the work Jay is doing for the conference. That's very good. A lot of effort there. And it sounds like it's shaping up to be a real nice conference. I'm sitting here fighting thunderstorms and things. I think we're going to start having alligators and crawfish in North Texas. People are going to start talking funny pretty soon. But I've got a SID station, my magnetometers, and I'm doing the space weather stuff, collecting data for that with 10-meter monitoring WWV and meteor cameras and keeping all that running with continuing power outage. We had a tornado about a mile or two south of me rolled through and covered a pretty big area. It was on the news quite a bit this past week or so. But keeping it going, trying to keep things running. And these discussions are inspiring, just like you said, the annual meeting are, to make you want to go do more things. So I have a lot of projects in the barrel. I need to put together some graphs and things one day to show here. But that's all I have.
Okay, great. And okay, last thing, 12 June for inputs for the journal. Everything you guys are doing, I'd love to have observation reports. If you've got an article written, we'll put the article in there, and then we'll get the journal out. If you've also got a proceedings article for the Eastern Conference, it's okay to duplicate them. All right, so if you want to do the same one for both, or just put your presentation in the proceedings, that's fine. We have nominations are going to be in the journal. we have four board members and 2 president, vice president nominations that for this year, for this year, and then 4 for next year. You know, we basically have 6 nominations each year between 4 board members and 2 officers. So anybody's interested in being in the working side of the SARA system, love to have you. And if you don't make one of those things, I'll assign you to a committee and put you to work anyway. So you can always use workers. And don't forget to sign in and get your swag from the gift store. Okay.
Can I fire off one more question to Ted? I've been running ezRA and with my little antenna, and like I said, I got like maybe 0.14 dB above the noise floor, and I can see in the primary display the hydrogen, but after running all the processing, I don't seem to see it anywhere. Is that signal too low to really process through the data through the process?
I think it's appropriate that we talk some more. Let's figure this thing out. I'm not sure I understand yet. Stay after the meeting and we'll talk some more if you want.
Okay. All right. Thanks, Ted.
Save the chat if you want. Open up the chat. Is it Alt-H, I think? And in the top right, there are 3 little dots. Click on the dots and save chat if you wish.
All right. And I'll have the chat in the YouTube underneath in the description. I'll go ahead and put the chat down there.
Yeah, Rich, can I ask you a question about the new SARA store?
Yeah.
I tried to go and buy myself a hoodie, but it didn't seem to give me any delivery options outside the USA.
That and I, at the beginning of the meeting, I mentioned that. I said I've got the USA figured out, and so you're my good test run here. UK doesn't work yet. Okay. So I want to see, it gives, now I have to figure out the international setup. It does have stuff there for international. I just haven't got to doing that yet. So let me try to set up the UK internationally. I'm gonna have to set up Australia and a couple other, Germany and a few other ones too, based on our users here. But let me try that, and I'll email you when I think I've set it up and let you try it.
Okay. Yeah. I apologize for missing the start of the meeting. Sorry about that.
Oh no, this is it's a brand new thing, and we verified that US works. I just haven't gotten to the international yet, so that's more experimentation on the gift shop.
Okay. Well, when you've done that, can I ask you another question? So sizing now. How big is extra large or extra large or whatever?
I have no idea. I have no idea. I get the biggest one they've got because but that's just me.
Okay, thank you.
Yeah. Okay, that's all we've got. And anybody who's want to listen to Ted and Jerry talk, I'm just going to turn off the recording now, and you guys can talk, and I'll just leave it on. You guys can have a good time talking. All right. Thanks, everybody.